Yeah, there are two words, I guess you might say, that we'll encounter on some probabilities, and sometimes they'll kind of be understood to be there. But one word is the word or, and we've I don't know that we've encountered it. Maybe we have before, but for probabilities, here's the thing. Usually, what or typically means, or means addition. You're going to add two things together, combine them, add them. That's, if you're looking for kind of a rule of thumb. Or means add. Okay. There's a slight catch though, and here's an example. All right, so let's say we roll a die, and we want to know what is the probability of rolling an even number rolling an even number or a number greater than 2. All right, so there's our word or. So if we kind of write it in our notation here, so we want to know the probability even or greater than 2. All right, so I mentioned here that, yeah, addition, if you want to look at these two individually, you got probability of even, and you got probability greater than 2. And we're going to combine those by adding them, because the word is or. Well, there's a slight problem with that. If I look at, so I'm rolling a die, so there's only 6 possibilities, right? 1 through 6 possibilities here. So the probability that it's even, well, you got 3 out of 6, and we'll leave that unsimplified, because we're going to have to add fractions. It'll work out if we don't simplify it better. All right, you with me there? 3 out of 6 is even. What about greater than 2? Which ones are greater than 2? 3, 4, 5, and 6. So there's 4 out of 6 that are greater than 2. That would be the probability that's greater than 2. And so you see, the problem with that, all right, so we're going to add those fractions. 3, 6 plus 4, 6 is, remember, if you got a common denominator, you just add the numerators. So that's 7 out of 6. What's the problem with that? What's wrong with 7 out of 6?
The top is bigger than the...
Top's bigger than the bottom. Yeah, the numerator is bigger than the denominator. You can't have that on probability. So there's a slight little catch, and the slight little catch is there's something we have to subtract. And the reason we have to subtract is we've kind of counted some things more than once. What we subtract here is the probability that it's both even and odd, meaning at the same time, even and odd. So which one of these possibilities are both even and odd at the same time? Well, not even and odd, even and greater than 2. Sorry.
4 and 6.
Yeah, even and greater than 2. They're both of these at the same time. For even and greater than 2 is 4 and 6. Yeah. So 4 and 6 are both even and odd at the same time. Let's see. Even and greater than 2 at the same time. So that's a 2 out of 6. 2 of them out of the 6 are both even and greater than 2 at the same time. So if I subtract that off, that works out, doesn't it? Because that's now 5 out of 6. And that is the correct answer here. Yeah, it turns out the formula for an OR probability, so it's the probability A or B equals the probability of A plus the probability of B, and we'll just shrink it down here and just say it's probability of A and B. But what that means is this is the probability that it is A and B at the same time. That's what that means, okay? So there's a slight little kink there in saying that or means add. Yeah, it does mean add, but you have to subtract off this. Okay, so here's another example for you. Is that okay? Any discussion or question about that? So here's another one. What if we have the probability let's do this one. Select a number from 1 through 10. So we're just going to select one number, and the numbers we can select from are 1 through 10. So let's do what is the probability that we select a number that is odd or a multiple of 3. All right, so we're going to use that formula right there just to kind of practice on it. Probability that it's odd or multiple of 3. All right, well, odd or multiple of 3 probability is equal to, by our formula, it'd be equal to then the probability of this one, probability that it's odd, plus, all right, it's or, probability that it's multiple of 3, but then we have that little bit we have to subtract, the probability that it's odd and multiple of 3, both. Okay? All right, so let's fill in the probabilities. What's the probability that it's odd? All right, so now we're going 1 through 6, we're going 1 through 10. How many odd ones are there in 1 through 10? Well, 5 of them, yeah, so it'll be 5 out of 10, odd. Multiples of 3, 3, 6, 9, would be the multiples of 3 in there. 3, 6, and 9, so 3 out of 10. But we have to subtract off the probability that it's odd and multiple of 3, meaning that it's both of those at the same time. What that means. So which ones are odd and multiples of 3 at the same time? Well, 3 is odd and multiple of 3, and 9 is. So there's 2 of them, 3 and 9, that are both odd and multiple of 3 at the same time. So I got to subtract off 2 of 10. And like I said, it works out better here if you don't reduce these because they'll have the same common denominator, and so you can just since we're adding and subtracting, you just 5 plus 3 minus 2 gives you 6. 6 out of 10, which now you can reduce that to 3 or 0.6. We're going to do it that way. Okay? All right. Okay. Now, another one here. Let me. This one kind of comes out of the book, so let me find it. let's do, let's just do this. All right, so let's say we, draw a card from a standard deck. What is the probability that we draw a spade or spade or a king? All right, so again, the way it works, you do the probability that it's spade or a king. You go probability of spade plus probability that it's a king minus the probability that it's both spade and king at the time. Well, there are, spades is one of the suits, right? So there's 52 cards, 4 suits, so there's 13 in each suit. Spades is one of the suits, so there's 13 spades out of 52 cards. Kings, well, there's 1 king in each suit, so you got a king of hearts, king of diamonds, king of clubs, king of spades, so there's 4 out of 52, but, for the kings, but we have to subtract off 1, well, spade and king, how many are there that are both spade and king at the same time? There's 1 of them, right? So, yeah, the deal is, you basically have you've counted that one twice, if you want to look at it, right? Because I've counted that king of spades here, and I've counted the king of spades here. So that's why the formula is what it is. You don't want to count it twice. But anyway, is that all right? Is everybody okay with that? So 16 out of 52 is what you get. Add and subtract the tops, which produces, that's just 4 out of 13. I did that right? Sound okay? All right.